Hello everyone, welcome to my YouTube channel named Sohel's Advanced Classes. So today we are going to study about Pythagorean Theorem. Okay, so let's get ahead and let's move on to my channel and my website Sohel's Advanced Mathematics. You can actually Google my name Sohel's and there you can scroll them or go to the site. Then there is top menu bar on the left hand side, that is fast simplification tricks. Then you can go for Pythagorean theorem articles. Okay, let's get ahead. Pythagorean triple article, and you can see this template Pythagorean triplet, Sohel's Advanced Mathematics, learn magical techniques with fun in a child's play, right? Then hello guys, I welcome you to officially here to Pythagorean triples. Pythagorean triples are very useful for fast solving questions and application in competitive exams because they are whole numbers that make the Pythagorean theorem true. If you are looking for the long length of a side of a right triangle and you know the lengths of two sides, check first to see if you have a right triangle whose sides are a Pythagorean triple or not. Okay, let's move back to the definition of Pythagorean triple. Actually, a Pythagorean triple consists of three positive integers a, b and c such that a square plus b square equal to c square. So c is the hypotenuse and a and b the sides related to the right angle, which is based on Pythagorean theorem. They are commonly written as a, b, c triple product, just a triplet. If a, b, c is a Pythagorean triple, then so is ka, kb and kc for any positive integer k. If we get multiplied k with this coefficient a, b, c, then that will become also in Pythagorean triple. We can describe it as you know that a square plus b square plus equal to c square. If I multiply k square both, the k square a square equal to plus k square b square equal to k square c square, and then k whole square plus kb whole square equal to k c whole square. This is the result. Our desired result. We can describe it as the sum of the squares of the two smaller positive integers is equal to the square of the largest positive integer. So the smallest and the best known Pythagorean triple is 3, 4, 5. The try. Generally, Pythagorean triple represents a right angle triangle whose right angle adjacent sides are represented by a and b and hypotenuse is represented by c. So I have made a small video by Pythagorean Python language, so you can watch it here. So this is the 3 square 9, 4 square 16, that becomes 25. Okay, you can observe that. Okay, or you can replay that video like this. That's green ones, then those brown ones. Okay, so I'll start on that. Clearly you can count such unit squares of equal sizes to prove Pythagorean theorem with example. Find that 3 square plus 4 square equal to 9 plus 16 equal to 25 and 5 square. So let's move into the classification of Pythagorean triple. So there are two types, one is primitive and another one is non-primitive. So what is primitive Pythagorean triple? Basically, primitive Pythagorean triplet is the one in which a, b and c are pairwise q prime or relatively prime. That is, they have no common divisor larger than 1 or they have GCD 1 or except 1, because if any 2 is divisible by a number, then other must be divisible by that number according to remainder theorem. I am let you know in the further remainder theorem. So there are some common examples of Pythagorean triple 3, 4, 5, 5, 12, 13, 18, 15, 17. So condition of generating a primitive Pythagorean triple. Actually this is not in your syllabus, but just I am going to prove that because I love to prove mathematics formulas. So choose any two positive integers m and n such that m is greater than n, say. Then for finding infinite numbers of Pythagorean triples, the fundamental formula is given by a equal to m square minus n square and b equal to 2mn, and thus c gets resolved by m square plus n square. Notice that because c is larger than a and b, sides hypotenuse to the adjacent sides of angle right angle. So notice that triplets generated by this formula are primitive only if and only if m and n are co-prime and not both odd or even. One of them is odd while the other one is even, and simultaneously vice versa. Let a, b, c be the numbers that form a primitive Pythagorean triple. So according to our definition, Pythagorean theorem, a square plus b square equal to c square, where a, b, c are co-prime, relatively co-prime. Means a and b are co-prime, then b, c are co-prime, and c and a are co-prime. Now a square plus b square equal to c square. Take a square to the right hand side, then it becomes c square minus a square equal to b square. This gives product rise to c plus a into c minus a equal to b square. Thus you can just of b square you write b into b. So c plus a by b equal to b by c minus a. Just notice this equation. Since a, b and c are positive integers, and sum, difference and product of two positive integers is always or also a positive integer, we simply set the above equality to equal with m by n in lowest terms, means no common factor left there in rational form, as m and n don't have any common factor to cancel out. So c plus a by b equal to b by c minus a equal to m by n. Just equate them. C plus a by b equal to m by n and b by c minus a equal to m by n. Then c plus a by b equal to m by n and c minus a by b equal to n by m. Then c by b plus a by b equal to m by n. Then c by b minus a by b n by m. So these two equations gets cancelled with the adding and subtraction each other. On addition equation 1 and 2 we have 2c by b, just see that 2c by b equal to m by n plus n by m, then c by b equal to half into m by n plus n by m. So c by equal to m square plus n square by 2mn. I have just highlighted the further one, the c equal to m square n square or b equal to mn, just come on this, subtracting 2a by b equal to m by n minus n by m, a by b equal to half into m by n minus n by m, a by b equal to m square minus n square by 2 by m. Just seeing the results in 3 and 4 equation, we can commonly generate that b equal to 2mn and thus a equal to m square minus n square and c equal to m square plus n square. So clearly comparing both numerators and denominators of equation 3 and 4, we have done that a equal to m square minus n square, b equal to 2mn, c equal to m square n square. Just to clarify that clearly, a square plus b square equal to c square. And as m by n is fully reduced, m and n are co-prime, they cannot both be even, otherwise 2 will be a common factor left there. Okay, so they can't be even, I have proved. So another one result I have to prove that they can't be odd together also. So note that any odd number can be represented as 2n minus 1 if n is a positive integer. Okay, now 2n minus whole square equal to 4n square minus 4n plus 1. So every square of a odd number leaves 1 as a remainder on dividing by 4. If m and n are both odd, the numerator of m square minus n square by 2mn, that is m square minus n square, is a multiple of 4 as a remainder of theorem, and the denominator 2mn would not be a multiple of 4, since 4 would be the minimum possible even factor in the numerator and 2 would be the maximum possible even factor in the denominator. This should imply a to be even because 2 left there in the numerator side, even despite defining it as odd. So by contradiction, m and n can never be odd simultaneously. Just to remember is that if you feel any doubt, just let me know in the comment box. I will get back to you some another video or that in the comment box too. Always I am for you service. Take just a common example. Take actually m is greater than n, so the lowest possible n equal to 1 because it is natural number, a positive integer. So m equal to 2, n equal to 1. Here taken a equal to m square minus n square, 2 square minus 1 square equal to 4 minus 1 equal to 3, b equal to 2mn, 2 multiplied with 2 into 1 equal to 4, c with m square plus n square equal to 2 square plus 1 square equal to 4 plus 1 equal to 5. Here we get 3, 4, 5 as primitive Pythagorean triple. This is the basic primitive Pythagorean triple which is used in most exams. Like this you can obtain any number of triplets. For your kind consideration, I have tabulated all 16 primitive triplets with c less than 100, the maximum hypotenuse less than 100. So how to find them? I have just a good formula on this value of m, then value of n, then triplet a b c. Okay, just look there. Value of n 1, so 2, 3, 4, 5 we get. If value of n is taken 2, we can take n 2, so we can take 3 because m should be greater than. So 3 means 3, 2 are 5, 12 and 13. Actually we can take any number of, then we can take 4, then we can take 5, here is 5, 2, 20, 29, then 6 we can take, 7, 2 we can take, like this. Okay, if I take 1, I can take 4 also, 4 1 is 8, 8, 15, 17. If I take 4, then 3 I can take. Actually I am just taking the value of m and just lowering the value of n so that they can be both even or both odd. So if I take 4, though there could be possible to 4 1, 4 2, 4 3, like this. 4 4 to 4 to cancel out, 4 1 and 4 3, then 5 if I take, then 5 2 only remains, 20, 21, 29. Okay, actually 5 3 can also go. So 6 1 as 5 12 35. The asterisk mark signs are denoting that these type of questions are completely asked in competitive exams. So just to cram them or mug up them or remember them by rote learning method. Then 5 4 equal to 9 40 41, or you can actually deduce that in the exam also. So 7 2 as 28 45 53 6 5 11 60 61 8 1 16 63 65 7 4 33 56 65 8 3 48 55 73. Then 9 2 36 7 7 8 5, then 8 5 39 80 89, then 9 4 65 72 97. So noted below that I think you had a clear idea of enumeration or denumeration. Okay, enumeration means the way of counting numbers, that by taking any positive number m as constant and take all n less than m from 1 to m, we get certain values of m and n from which we can get all Pythagorean triplets. From this, the necessary condition should be aware that m and n is opposite category. When one is odd, other is even, not both, then it gives up primitive Pythagorean triplets. And one should note that m is always greater than n. Others such pairs gives us multiples of these primitive triplets. So star or asterisk denoted triplets are common and should be memorized for competitive exams, as I already warned you. Non-primitive triplet. Any such triplet that cannot be or are not primitive Pythagorean triple are said to be non-primitive triplets. These are simply a number, these primitive triplets simply a number times, right? So a non-primitive triplet can be obtained by inserting an additional parameter k to the formula of primitive Pythagorean triple. The following will generate all Pythagorean triples uniquely: a equal to k into m square minus n square, b equal to k into 2mn, c equal to k into m square plus n square. So example 9 12 15 is a non-primitive triplet because it can be thrice of 3 4 5. Like this we can multiply any number to primitive Pythagorean triple to make non-primitive triplets. Hope you enjoyed reading these concepts that are written with my efforts to make you understand the concepts easily with necessary proof. If it would definitely help you a lot to solve problems asked in exams and daily use actively, especially in 9th and 10th exams, just the mensuration ones. You can share this article to all school children with your teachers, which can help them in mensuration and seminar, moreover to grasp concepts in a better and magical way. Let me know if you have any query and I will put forward my level best to solve those questions of yours to the extreme extent. Till the enjoy reading this over and over and try to apply in such problems. So here are pretty good impressions there, and very great bow, very helpful, why kya baat hai, very helpful, and this type of comments. So I think they really like this. Okay, and I hope you certainly like this type of comments. And here I am signing off this session. So else out, yours lovely one. Okay, bye.